This talk is about how the internet works. It's amazing how people, even software developers, have no idea how the internet works. So, how the internet, and we're going to talk a little bit about protocols that make the internet actually work. Let's talk about, first off, what is the internet? And there you go. It is simply a vast interconnected network of computers, right? It is the physical structure of computers and routers and switches and cables, right? It is the physical structure that enables information to be transmitted across the entire planet at this point. Now, each type of, and we'll get into this a little bit, there's different types of communication, there's different types of ways that information is transmitted from computer to computer across the globe, and those require different protocols. So we'll get into that a little bit as well. So we're going to talk about the internet and all of the protocols that make the modern web and all of the other types of applications that we use work. All right, so what is the World Wide Web? This is something that people often conflate the two. They are actually separate things. The World Wide Web is by far the most popular application that is transmitted across the internet. I'm sure you've seen some of these acronyms before, like HTML and HTTP and URLs, right? These are all, components of the World Wide Web. And it was created really just for people to send information, like truly text information and share knowledge with each other. That's really what the World Wide Web is all about, sharing information with each other in text format. And that's what HTML is. So it is just one of the applications that the internet delivers. It just so happens to be by far the most popular application that the internet delivers. There are many different layers and different types and subsets of internet. And I'm going to go into each one of these. And it starts from local area networks to WANs, to points of presence, to network access points, and then finally the global internet. These are all different like sizing and scales of internets. And they are all different types of internets, right? Because they're all just different layers of complexity of networked computers. So let's talk about actually the simplest kind of internet, the kind of internet that my brother and I had back in 1980, when my grandfather gave us two old TRS-80s, and we set them up back to back to each other, and we used something that looked exactly like this, an RS-232 cable, and we connected them to each other so that we could send information back and forth to each one of our computers. Right? That is an internet, right? It is networked computers through a single cable, the simplest kind of internet. So now we get into what modern people, or terms that you probably have heard, more complex networks. So the first one is LAN, right? The local area network. So a typical topology for this one, think about it just like in your home, that's a LAN. If you work in an office, right, everybody connects to each other's computer, has access to everybody's computers and the printers and the servers, right? So within a very, very specific location, like a building, is what's called a local area network. And all of those devices connect through something like I call it a router or a switch, so they can communicate with each other. So more than two, but less than a lot, right? 2, 4, 6, 8, 10 computers or devices connecting to each other. That's a local area network. Next up, we have a wide area network. So you can just think about this as you take several local area networks and you make them communicate with each other through a little bit more sophisticated technologies, more devices, more sophisticated servers, more sophisticated routers. So like an office complex downtown, where you may have 5 buildings, each of which has their own LAN, but they connect with each other to send information between computers. So now we're talking about a wide area network, maybe a small community or, like I said, an office park, things like that, right? So routers and switches and modems, these are all pieces of hardware that enable these things to connect multiple local area networks together. Next up on tier 3, we have what's called a point of presence. This is typically what most people who deal with networking, they're communicating with their local point of presence. And these are operated by internet service providers, Verizon, Comcast, AT&T, even like local regional internet service providers, right? So they provide what's called a point of presence that serves a much wider geographic area, maybe an entire metropolitan area or, southwestern Illinois, northeastern Pennsylvania, right? So a larger geographical area. And they'll serve, hundreds, thousands, tens of thousands of customers. And they will offer other things, not just direct access to the internet, but a point of presence provider. You can see at the bottom, they often provide additional services like security and data storage and very, very small scale cloud computing services, right? But they serve larger geographic areas than a wide area network would, but still not that big, right? We're still not up to the global internet yet. All right. Another type of point of presence that has its own name is called a network access point, right? So let's say that the United States currently has 20,000 different points of presence that serve different geographic areas. Well, network access points are what the points of presence use to communicate with each other, right? So the United States may have like only 100 network access points. Now, these are typically owned and operated by the major telecommunication providers, the AT&Ts and the Verizons, big European companies, I think Orange or something like that, Skynet. So these, just service, trillions and trillions of communications every day, information being sent through these, and then down to more specific points of presence, and then off to the customers. And, they'll serve anywhere from, maybe a couple thousand people if it's somewhere like in rural Africa, versus a network access point, let's say that's in New York, that may serve, tens of millions of people. Different scales for different points in the world. And then finally, we have the global internet. Now, the global internet, what has truly made us a global community, is what is called the submarine internet map, right? So I'm going to click on this right here, and we're going to take a look at how the entire world is connected through undersea cables. And there you go. There is a map of every single undersea cable that connects these coastal network access points to other coastal network access points on different continents. And you can see where, like the Caribbean, because there's lots of different islands, there's lots of places where these make landfall on the coasts of all these different islands. So even a country as big and as much traffic that North America serves, there's what, 1, 2, 3, 4, 5, 6, 7, 8, maybe 9 or 10 on the eastern coast. And as the traffic comes in here, it just spreads throughout the country to other network access points, then down to points of presence, and then down to the final customer. But this is how they're all connected, including this lonely little undersea cable way up here. How can I scroll up? There we go. There's one way up here. Look at this lonely little guy right there. Whatever this is, apparently it's owned by Norway. So if I hover over this, you can see the Svalbard undersea cable system to one little city sitting way up here. To Svalbard, Norway. So even Svalbard is connected to the entire planet through all of these cables, including this weird one which goes across almost like the Arctic Circle on the northern part of Russia. And as you can imagine, Asia has a lot of cables running around the oceans there and a lot of network access points on the coast connecting in all these different locations, particularly between China and Japan. So there you go. There is the global internet that allows you, wherever you are, to connect to any other device anywhere in the world. So we truly are a global community, a global internet. All right, so that is just the physical structure and how it all works, right? The actual like hardware. But what enables all of this information to flow? Well, some very smart people, I put just a small little image of this watershed paper that was produced by the RAND Corporation. Paul Barron is the main author in this, but also Charlotte Bowen. I can't even remember the year, but it was, there it is, 1964. On distributed communications, they laid out in this paper in 1964 how we currently transmit data across the global internet. They figured it out. And it came out of that paper after several people tried all these different protocols was something called TCP/IP. If you want to really know how information is transmitted from computer to device to computer, doing a dive into TCP/IP is well worth your time. I'm going to give you a very, very high level overview of what this actually does, these protocols. So TCP means Transmission Control Protocol, and IP means Internet Protocol. Now they've gotten squished together, separated by a slash, into basically one protocol, just called TCP/IP. Now, what these are largely responsible for is you've got one computer that wants to connect to another computer. Let's say you want to hit a GitHub server, but that GitHub server is located, let's say, in Baltimore, Maryland, right? So you initiate a request to github.com. And what happens is this long series of communications happens between you and that computer. So an initial handshake is established so that the two computers know some basic information about each other and what the capabilities are. Then, as the data is transmitted between the two, what is the information is broken down into what is called packets. Now, let's say that the server at the GitHub side of it says, I can only handle packets that are 4,000 bytes long, but you want to upload an image that is 85 megabytes. So what the TCP/IP protocol does is it breaks down your 80 megabyte picture into thousands upon thousands of 4,000 byte long packets. And then it transmits each individual packet across the internet to that final destination. So the person on the other end, it just waits. It knows how many packets are going to be sent. That was part of the original conversation. So it just sits and waits for all of those packets to arrive. It numbers each one of the packets because you can't be guaranteed that all of the packets are going to arrive in the order in which they were sent because of the distributed nature of the internet. So the receiver, the TCP/IP protocol, will just wait for them all to come in. Then it will reorganize them in the correct order in which they were broken down, reassembles them, and then finally the receiver of the data has the data and they can do something with it. And then the internet protocol aspect of it really just helps the transmission of it across the internet. What is the most efficient way for it to get there? Where exactly am I going in the world? You know, what parts of the internet are possibly down that I need to avoid? Again, very high level overview. I'm not going to get into the nitty gritty details because that would take 2 hours just to talk about the internet protocol. So you can see down here at the bottom, it handles flow control. It knows where to go. Congestion control, that's really busy, so I'm going to go some other way. Error detection, I know that part of the internet is completely down, so I'm going to go another way. And then correcting, right? Putting things back in the right order in case something fails. This is all part of the TCP/IP protocol. This is what makes the world work today. If it wasn't for this protocol, we would not have the web. We would not have email. We would not have the ability to log into other computers on the world. It all came from this undistributed computing paper, which isn't that long if you're ever curious and want to read it. Okay. So there's the TCP/IP protocol, another game changer. So let's roll the clock back to when I first got on the internet. I think it was 1992. On my computer, there were no domain names. If you wanted to connect to another computer on the internet, you had to know its IP address, the numerical IP address. So everybody back in the day either had a notebook or like a text file on their computer that had the IP address and then like dash, right? Whose internet, you know, or yeah, IP address that is for, like Genie or, you know, ESPN or my friend's bulletin board, right? So we had to keep track of all of that. Now, the internet exploded really fast after that. So by like 95, there were so many IP addresses, people just could not keep track of it. So they came up with a domain name system for something that is far easier for us as human beings to remember, things like Microsoft.com, Apple.com. That's a lot easier for us to remember. So what that does is it maps that human readable name, domain name, to a series of IP addresses. So we don't have to remember those numbers anymore. This was one of the biggest game changers that allowed the internet to explode back in the 90s, because nobody could maintain that many IP addresses and know where everything went. So, benefits of DNS. Well, obviously, faster website access, because you can remember the name of the domain far better than you can remember the IP address. The DNS system has caching at all different levels, from your computer and your browser up to internet service providers, and even the DNS infrastructure itself caches a lot of these things. So it's not constantly always looking up at the core domain name registry. They distribute that cached information to all different locations. So it makes things faster. Another benefit of DNS is load balancing. This is actually built into DNS. So if you have a domain name, you can actually map, n number of IP addresses. Let's say you have different IP addresses that you want to publicly make available for your domain. DNS can actually, like when a request comes in for your website, it'll ping the first IP address. But if that one's super busy or down, it'll just reroute that traffic to the second IP address on that list. If that one's down, it'll reroute it to the third one until one of those IP addresses, meaning one of the servers, is actually available to handle the request, right? So that is actually built into the DNS system itself, a little bit of load balancing. Not a whole lot of people use DNS load balancing. Most people use software or hardware-based load balancing these days, but it is still used. Huge benefit of that. Highly sophisticated piece of technology. All right, here are the most common protocols that you're going to see on a daily basis. Now, as web developers, the first one is probably pretty familiar to you, the hypertext transfer protocol, right? That's the actual text, right, that we see on a web page, right? The H1s and right, the actual web page that we want to see. Hypertext is linked text, right? So that was the original one. Well, then we wanted to send mail to each other. So the simple mail transfer protocol came up with, right? And that is what email is driven by. It is a completely different protocol for how the data is structured, how the data is broken down, and how the data is transmitted. File transfer protocol, which was very popular back in the 90s, not as popular now. Believe it or not, before you guys went out into the field and you discovered these things like CI/CD pipelines and DevOps, you know what we did back in the day to get things into production? We used an FTP client that had a direct connection to the production server, and we would click and drag a file from this panel to this panel, and that is it. That is how it got to production. And that used the FTP protocol. It transferred a file. And then lastly, you have the secure shell protocol, and that's what allows people to securely connect to a shell on a different computer and actually run commands on it. Right. And so it allows you to do that with strong encryption, so that nobody can sneak in between you and the server you're trying to connect to and like steal that information. Right. It is a secure shell. These are all the underpinnings of how data is transmitted. Now, TCP/IP is how things are broken down. These are more how they're structured. All right. So back in the day, there was only HTTP. Everything was sent across the internet completely unencrypted, plain text. Now, as businesses started to come online and put their websites up there, believe it or not, they wanted to make money off the internet. They wanted to sell their crap to us over the internet. Now, it's not very good to transmit passwords for user accounts, credit card numbers in plain text over the internet. That didn't make people very happy. A whole bunch of security protocols have been invented since the beginning of the web. The most popular one is SSL, and that's why sometimes you have to put HTTPS:// into a URL, and that enables encryption by default. All of the data will automatically be encrypted between you and the destination. Some of you may have to connect to your company's network via a VPN that has its own security protocol called IPsec. And as wireless internet became popular back in the 2000s, again, people did not want somebody sitting outside their house being able to be the middleman between you and your router, right? Because that's something that somebody can do, right? So they had to come up with a Wi-Fi protected access security protocol so that nobody can listen in on a conversation through a wireless connection, because the other two are for wired connections, where you literally have a cable running from a device to another device. WPA is for wireless. So these are all things that were created to make the web more secure so that we could transmit very sensitive information without anybody feeling it. And that is my last slide. I told you guys it wouldn't last that long. So there's a brief kind of history lesson of how the internet works, how it kind of grew up over the years. Because it had to grow up a lot. The early web was just a way, honestly, for like scientists, professors, and researchers to share text with each other. That was it, right? They wanted to publish a paper, or they wanted to talk to each other on what were called bulletin boards back in the day. That was it. That was the web, just sharing text with each other. But as people started to really understand the power of it and got onto the World Wide Web and started registering domains, they realized they could cash in on this as a way to directly access a customer and a customer to directly access a business. And that's when all of these additional like security protocols and additional like the DNS system all came out of that as well. So the internet grew up in many, many different stages and had all of these different applications start to be delivered over it as time went on, right? HTTP was the original one, then SMTP, then FTP. Heck, there used to be a protocol back in the day called Kermit, believe it or not, which was a type of file transfer protocol. So there you go, gang. That's how the internet actually works. And it is not the World Wide Web.